An array is a linear static data structure used to hold numerous values of the same data type. The characteristic linear means the data stored in an array is arranged in a sequential or linear manner. The characteristic static means the size of the array, meaning the specific number of values the array will hold, cannot change once the variable is initialized. An array is used to store numerous values of the same data type in a single variable. An array can store any primitive data type or object type as long as all values stored within the array are of the same type. For example, instead of declaring a new variable for each test score, as seen here, all test scores can instead be stored in one array. In doing so, each value is assigned and can be referenced using what is called an index. So looking at this representation of an array, we can see that the value 98 has an index of 1, and the value 99 has an index of 5. Notice the first index is 0. If you are new to programming, this may seem strange to you as we are typically taught in grade school to start counting at 1. While there is a good reason behind making the first index 0, we won't discuss the details at this point in the tutorial series as it may lead to unnecessary confusion. Instead, the details will be posted in a later video. For now, all you need to know and remember is that the first index of an array is 0. So in this example, the value 100 is stored in index 0 of the foo array. Now if we wanted to reference a specific value in the array, we would do so by typing foo followed by brackets with a 3 inside of the brackets, or foo sub 3. An array can be declared in different ways. How you declare an array is up to you, just be consistent in how you do so. For example, we can declare an array in the following manner. The first line is the actual declaration of the array. At this point, the array has no size and contains no values. In actuality, without giving it too much thought, all that has happened at this point is a CPU memory address has been stored in the variable foo. Now in the next line of code, a specific amount of space is reserved or allocated depending on the value placed within the brackets. In this case, enough space to hold 20 int variables is allocated. Remember that since an array is a static data structure, once the space has been allocated for any given array, that amount of space remains the same as long as it exists. Now both these lines of code can be consolidated into one as seen here. Also know that this declaration can also be written like this, with the only difference being that the brackets are moved from after foo to after int. These are all valid ways to declare an array of integers, and as mentioned before, how you decide to declare an array is up to you, just be consistent. Now notice that the declarations use the reserved word new. That is because in Java, arrays are objects, and we must use the reserved word new in order to declare objects. After the integer array has been declared in this manner, all 20 spaces of allocated memory will be initialized to 0. If we wanted to store new values in the array, we would do so by using the array variable name, followed by the index that we would like to store a value in, and then the assignment operator as seen here. This may be the best route if you do not know the exact values that the array will hold at the time of declaration. For example, if you have a class of 20 students and you are going to input all 20 students' grades into an array, however the grades are not known to begin with and will instead be inputted individually at undetermined intervals, this would likely be a good approach. However, if we know the values that we want to store in an array at the time of declaration, we can instead declare the array using an initializer list, as seen here. Notice that when we declare an array using an initializer list, we do not have to use the reserved word new. Let's look at an exercise to better understand arrays. Using the first method shown to declare an array, first we will declare an array called foo, and we will initialize the integer array foo to contain 20 integer values. Once again, as mentioned before, notice we can move the brackets from after foo here to after int, and we won't get any errors as this is also an acceptable way to declare an integer array. Next, we will use a for loop to print out the value stored in the array after it is initialized. Notice in the for loop termination expression, we are using the method length to get the size of the array. This is possible because arrays are objects in Java. In fact, you can see there are numerous other methods we could use without ever creating them ourselves. When we run this program, we see that all values are 0, as they should be since we have yet to explicitly assign any values to this array. Let's do that now. We do so by typing the name of the array, in this case foo, followed by the index in which we want to assign a value to in brackets, then the assignment operator, and finally the value that we want to assign to the index. We will assign the value 30 to foo sub 3, and the value 12 to foo sub 8. And when we run the program again, we can see that the value 30 was indeed stored in foo sub 3, and the value 12 was stored in foo sub 8. Now, if we wanted to print a specific index to the console instead of the entire array, we can do so by referring to a specific index in the print line statement as seen here. Now let's look at declaring an array using an initializer list. This time let's create a char array. Notice we are not using the reserved word new as it is unnecessary, and when we print this array to the console, we can see that everything prints as expected. There is one last thing to cover in this video. What if we change the termination expression to be I is less than 4? What do you think will happen? Let's run the program and find out. You can see we get an exception. The exception prompts index 3 out of bounds for length 3. That is because the loop is executing a total of 4 times. Once while I equals 0, once while I equals 1, once while I equals 2, and once while I equals 3. However, the char array bar only has a size of 3. Therefore, the printline statement is trying to access part of the bar array that does not exist, a fourth element that would be stored in bar sub 3 if we had initialized a fourth value here. Whenever this occurs, Java has implemented a way of handling such a bug by throwing an array index out of bounds exception, as seen here. While it is great that Java somewhat handles this issue for us, it is important that additional logic is added to code should there be a possibility that an instance such as this one would occur during the runtime of a program.